A repeated theme in this course is writing programs that meet a numerical standard for elegance or conciseness. It's not enough to write working code. You must also write code that is no more complex than some threshold, as measured by a complexity metric. And this lecture looks at the code complexity metric that's used in this class. Now, the exact rules for the complexity metric are given in the IHS documentation, which is linked from any code-based IHS exercise. As of this writing, the link is IHS root, whatever that might be, and docs graders code grader rule a.html. So please find and read this document before going further. As the document explains, assuming you've had a chance to read it now, the complexity rule assigns complexity points based on the keywords, variables, and operations that you use. For many of the point assignments, the document also offers rationales that are worth understanding, partly because they'll help you remember the rule, but also because they discuss code patterns that are desirable and not so desirable. So, question 1 here, just as a reality check on your reading. What would the cost of this expression here I'm showing be, and it's in the notes as well, of course, assuming it's not nested inside any loop? And then a follow-up, what might you do to reduce its cost? So, coming back from a pause there, answering the first question, well, the 5 variable references of A, B, D, C, D each cost a point. And then the 4 operands, including the assignment, which is an operand, each cost a point. So let's see, that's 5 plus 4 is 9. And then we also are going to be charged for the parentheses. Each pair costs a point, and that brings us to a total cost of 11. Now, improving it. The parentheses are needless, so we can reduce the cost to 9 points just by cutting those out. And in fact, we can rewrite the expression just a little bit more elegantly because D is used in both terms, and do a B plus C times D. And that actually has a cost of 8 points, even though it requires some parentheses. So question 2. What's the point of charging you for using parentheses to group operations? I mean, you can't help the fact that some operations have higher precedence than others. What code elegance behavior does the document say is the rationale for that? Coming back from a pause and looking it up in the doc itself. Right here under 1-point charges, it says pretty clearly the rule is to encourage you to avoid parenthesizing when precedence will take care of the order. As for the instance of question 1 that we just looked at, although, interestingly and intentionally, it's not enough of a charge to offset the advantage of distributive refactoring, as we did in question 1 when we rewrote it. And that brings up a larger topic worth discussing here. Are these rules meant to push you toward perfect coding style? Now, indeed, there is no such thing as perfect coding style, since style is a subjective matter. People differ over terseness versus clarity, for instance. Should I write this, for example, with parentheses? Or should I expect the reader to know that plus has a higher precedence than shift and write it more simply without the parentheses? Should I use language shortcuts? For instance, writing something like if A, when what I mean is if A is not equal to 0, or chaining assignments, A equals B equals 1, for instance, which is allowed in C, instead of using 2 separate assignments. And if shortcuts are okay, then does anything go? I mean, is it okay to write things like A equals 1 plus B equals C, because I wanted to assign B to C along the way there. And again, you should know enough of C to understand that that is actually legal code. Well, this course's complexity metric tends to favor brevity and moderate, which would be like that and that, but not extreme use of language shortcuts. In other words, that would be disallowed, or at least would cost you more. Some programmers may differ with this choice, but fine points of style really don't matter as much as the main educational purpose of the complexity metric, which is to get you to consider different ways to write your code and to make it more elegant in broad terms. It has, in fact, been said that there is no great writing, only great rewriting. That one, by the way, is from Louis Brandeis, and you can find dozens of similar comments from many noted writers. Now, programming is a highly quantitative form of writing, and as such, it benefits from revision as much as standard prose writing does. Most writers learn their craft by repeated revision of their work, and so do most programmers. Regardless of whether you agree with every aspect of the complexity metric, the very process of revising your code to be more elegant is a useful educational experience, and it'll make you a better programmer. Any reasonable set of rules would serve just as well. It's the process of revision that is the essential point. Now, that said, please do report any case where the complexity metric encourages you to do really ugly things. The current metric has a number of revisions resulting from just such reports. For instance, an early version counted just 1 point for each string constant, and that induced people to create huge textually meaningless string constants to hold numerical tabular data in ASCII code form. Now there's a charge for really long strings that blocks that temptation. Now let's take a look now at some of the more complex point rules in the metric, both to be sure they're understood and to give a bit of rationale for each. First of all, control structure charges, under the 2-point category here. As you can see from the doc, any use of control structure, if statement for instance, or loops, are charged 2 points. Now, control structures already incur the cost of their tests and their increments, but some additional charge seems reasonable just for using a loop or if statement, including each additional else branch, by the way, of the loop or of the if statement. And let's do a quick exercise to see if you are understanding exactly how the rules would be applied. For this code here, what would be the charge, the entire charge for that body of code? Coming back from a pause there. Well, the test itself, for instance, costs 3 points. An operator and 2 variables, of course. And then the bodies cost 2 points apiece, using their plus operators there. And that plus 2 points for the if statement itself, and another 2 for the else, come to 11 points total for this construct. Now, a brief comparison with a traditional way of measuring code complexity is worth talking about here. There are various classic code complexity metrics. Among the most noted is cyclomatic complexity, and you can look that up if you like. It's in effect a charge only for control structures. Under cyclomatic complexity, a program with no branches or loops gets a complexity of 1, regardless of its length. Now, each addition of a loop, or if statement, roughly speaking, adds another point. And this is justified by the argument that each control structure adds new possible paths of execution through the code, and the number of different execution paths through a program strongly affects its testability. But cyclomatic complexity has the obvious weakness that it rates a 100-line, non-branching block of sophisticated mathematical assignments as less complex than a simple 2-line loop. We're trying to measure subjective readability, so counting only control structures just doesn't make sense. A reasonable compromise seems to be charging for the tests and the increment operations that a control structure might need, plus a nod to cyclomatic complexity by charging another 2 points for the very existence of the branch or loop. It also makes sense to charge 2 points for function declarations, by the way, in the same subjective readability basis. A function already gets charged for its formal parameters and for the actual parameters used in each call of the function, as you can tell by reading the rest of the document, but a modest additional charge for just declaring a function seems warranted. And another in-lecture question here, number 4. What does this function call I just wrote up here cost? You may need to look at other points in the document to get a sense of what the charge is for various parts of the expression there. Coming back from a pause, the x plus 1 costs 3 points. The use of the function name square root, that's a variable, costs another. And the parenthesis function call operation, and remember that is an operation, adds a 5th point. So 5 points. Okay, let's talk a little bit about what I'll loosely describe as special charges. The metric includes a number of higher point charges, carefully designed to allow certain coding practices while discouraging abuses. And perhaps the most classic such topic in C is the question mark colon operator, which gets a 4-point charge. Now, this is much more than the usual 1-point charge for an operator, but the conditional operator is really an if statement in disguise. Question 5, for instance. The document maintains, as you can see here, that A equals B less than C, colon C, question B, that is cheaper than the equivalent if statement. So what are their two costs? How much cheaper is the conditional expression than its equivalent if statement? And coming back from a pause there, first thing to do is look at what the equivalent if statement would be, and that's what it is. So this would test B less than C and assign A accordingly. And let's look first at the cost of that if statement. The cost of the bodies of the two branches, 3 points apiece, is a total of 6 then. The test, another 3 points, brings us to 9. And the if costs 2 points, and the else costs 2 points, so we're now at 13 points. Now, by contrast, the conditional operator has 5 uses of a variable, so it's 5 points plus 2 ordinary operators, less than and the equal. That brings us to 7. And then 4 for the question mark colon, and that totals to 11. So it's 2 points cheaper. Now, another special charge category is for flow breaking statements, like break, for instance, and continue, and return, except as the last statement in a function. Now, some stylists forbid these altogether as hard to read. That's extreme. But a 10-point charge makes them worth using only in cases where they would save at least the cost of a line or two of code. Similar reasoning applies to switch statements, which have an awkward, old-school syntax, as anyone who has forgotten a break statement within one will testify. But they can be more readable than if-else-if blocks for large numbers of branches. Switches would have been effectively forbidden by charging 10 points for each break statement. Instead, the break at the end of a switch, or at the end of a case, I should say, is free. But there's a 10-point charge for the switch itself. If you do the math, you find a switch wins over an equivalent if-else-if when there are at least 8 else branches. For if-else-if for smaller cases. Now, there are also 2 very high charges for discouraging the use of universally disliked constructs. A goto costs 20 points, and a non-constant global costs 100 points. In certain cases, the goto might still be worth it for breaking out of multiple nested loops at once, but only if the alternative loop test logic is quite complex. The non-const global will never be worth it, and shouldn't be. Now, moving on to one of the more complex rules in the complexity metric, having to do with nesting. Any code within a loop gets surcharged by 20%. And the 20% is compounded for each further loop nesting. That means that code inside of 4 nested loops, for instance, would be charged or surcharged by a factor of 1.2 to the 4th power, and that it means it's nearly twice as expensive as it would be standing alone. The obvious rationale is that complex loops, especially deeply nested ones, are hard to understand, and you should factor as much code out of loops as possible. Now, there is no nested code charge for if statements. Reducing code in an if statement almost always involves removing duplicate lines from both the if and the else branch and putting them before or after the if. Like this, for instance, where we would take A equals B and drop it afterward and factor out these 2 lines instead of repeating them like that. And in that kind of a case, the cost reduction of removing one copy of a line is adequate incentive to simplify if statements. And then a final point. Long functions also get a surcharge. Now, like nested loops, this takes the form of a compounded percentage implied to the entire complexity count for the function. There's no penalty for up to 250 points, and a gradually increasing penalty as a function's complexity grows above 250, such that it doubles for every 250 points thereafter. Now, the penalty computation is rather complex, 1.0035 to the power of the excess points, but ideally you should never need it, because the main point is to keep your function complexity under 250 points. So why not just make it a hard limit? Because experience has shown that any hard limit on function complexity results in much carping about having to break up functions that are just slightly over the limit. Couldn't you raise it to 260? A gradually increasing penalty avoids this. For instance, a 260-point function costs you just a 10-point penalty. So you can push the boundaries a little, if it's really worth it to you, but not much. A 300-point function costs you an extra 57 points, for instance.